And in the next exercise video, I'm going to do something completely different.
This story starts on a dark and fateful day a long time ago, when two valiant knights of the Makerhoods started their heroic battle with two sheets of ancient plywood that had seen the hardest of times. Upon their knees, equipped with the primitive tools, the two brave fabric cobblers turned their wits to their strength, and after a long and tough battle, they eventually conquered the battle-torn plywood. Celebrations were later held to the dawn of the next day, feasting on several cold snacks and bubble pops. Stories were told, laughs were had. The dudes of the Spanners had entered the history books.
Anyway, the plywood is held on with these headless bolts. One way of removing them is to weld on a metal bar, then undo the nut from the underside. This works quite well if you can't get a vice grip garage on the headless nut. Some of the nuts were really difficult to access, so we started cutting some access holes with this oscillating tool. It had about the same bite as a sardine attacking an elephant. We quickly resorted to the classic and tried method of ye old drilling and jigsawing method the Romans had devised. That worked really well. If the plywood is well aligned with nature and time, you can easily remove some of the rotten, organically sympathetic plywood with an angry spinny brush. Then you can use the correctly sized spanner on the headless bolt and undo the nut as per the manual. Last time the flatbed side boards are on.
Yep.
Next is grindery.
Angry.
Angry, yes. Today, on the 7th of June 2021, we, so to say, broke ground. That is the start of building the camper started. This is the day. There is no going back to this being a flatbed anymore. Everything we've done so far has been reversible. Basically, this profile has been on all the way here. I'm sure I can show you some pictures of it beforehand, but then we had the loading points here with the shackles and things like that too, so all of that is now going from this side. Yeah, let's build a camper. I'm in the process of taking of the lights and the light hangers and all of the gubbins that are back here that we don't need. As you might know, we are quite weight conscious. Not in the stick my fingers down my throat after 6 Big Macs, but more like, why is this thing weighing this much for no reason kind of way. Therefore, it should be no surprise that our curiosity had us weighing all the lights etc. that we took off. For the record, the arms that hold the lights are 6 and 7 kilos respectively. The lights themselves are 1.5 kilos. In total, we removed about 20 kilos. Yes, some of it will have to go back, but maybe replaced by some more suitable items. Removing the battery box was no problem. Isolate the switch in the cab and start removing bolts and wires. There's a surprising amount of bolts and nuts holding this contraption together. It's nothing difficult, just that there's way more of them than I expected. Just keep the positive attitude and make lightning work of it. Don't do anything negative or you might find yourself grounded. This is the model I created in Fusion 360 to figure things out. What I needed to figure out was the distance from the first step to the camper floor and the second step, and I wanted these heights to be the same. And the way we did this is that we added all of these variables into the parametric modeling system of Fusion 360. By utilizing this, I could play around with step height, insulation height and various other things. So if we take off the insulations here, we have a basic floor skeleton here, and then I can play around with this and I can check the distances between various surfaces and various other properties that were critical. So here's a crude model of the frame rail. You know that it does bend down, and these red blocks are the ones that are sort of the danger zone. And what I can do is that I can select a surface or a point, and I can then measure these things, and I can see that this one here is 100 millimeters, which means that it should be okay. But the key point here is that by altering all of these values, I can easily move things around and see what is a reasonable clearance and reasonable step height and all of that thing. So another thing that we can check is what is the distance between the first step and the floor. So the first step and the second step is 235 millimeters tall, and I can change that depending on what I want to do. But one of the things that I found very difficult is that because we need to have insulation on all of the things, which way do we put the insulation in, and where is the levels between them? So here is another one, and this one says that it is the same, 235 millimeters. So that's a pretty good step for what we thought would be a good idea. To cut a long story short, I used Fusion 360 and parametric modeling to figure out the dimensions and the height of the floors and all of those things. Thanks to the parametric modeling, I can play around with the numbers and see what works. With this figured out, I can then generate a plan, a drawing for it that I can take out to the garage and use. Now, with the battery box removed and all the other gubbins are gone from here, I'm now really running out of excuses not to actually do this work. You might be able to see the green lines here. They are incorrect, and we thought that this front pivot point there needs to have 12 degrees of movement. At this distance from the center, 12 degrees is 24 centimeters. That is from that green line up to that green line, with the center being there. I'm pleased to say that we got it wrong. This here is one of the Mercedes Unimog manuals of how you modify this vehicle. To be a bit more accurate, this is for a newer model. I don't think that there is one for the 1980s military one, but what's in that one applies very much. This part of the truck has not changed very much in many years. The changes are mainly transmission and engine emissions and all that stuff. The actual mechanical platform has stayed very much the same. In here we found that from the non-pivoting points, I can't remember what they're called, I'm sure Kaz will come in here and tell you, there is 4 degrees of movement of the frame rails per meter. So around here, which is just around a meter, we have about 4 degrees of twist on the frame. And this is again one of the assumptions. You kind of think that it is the flatbed that moves around, but it's not. It's actually the frame underneath twisting from that point forward. So the frame twists underneath there. And again, we got this wrong thanks to the manual. Kaz managed to figure it out. I'm too dumb for that sort of stuff. So it was up to me to spend time in Fusion to try to determine a spot, how much space we have when things move around. It turns out we have a little bit more space than we thought we would, but still there is going to be wasted space between the body and the frame because it all needs to move, and we can't have this go wrong. It doesn't, this isn't a, well, Robin's a bit of a racing or something like that. No, this is, if it touches, it's bad. So now, with the battery box removed and my excuses running low, I now actually have to start properly figuring out whether this drawing is going to work. So the next thing I'm going to do, I'm going to make this profile, i.e. the step and the second step and the thing and all that stuff. I'm just going to make a profile out of cardboard to verify my CAD model. So I'm going to make a CAD model to verify my CAD model. Yeah, anyway, enough waffling. Let's see what happens. So the thing with the CAD model isn't happening at the moment. We've just spent half an hour, 45 minutes just sitting here talking about where we should start and how we should do the CAD model. And the problem here is, as usual, if I make a CAD model, it's going to be a compromise because there are things in the way. So, yeah, that's not going to be very productive, is it? So, after a lot of deliberation, I'm just going to start cutting things off. So wish me luck, this might get ugly. I hope you can hear me. There is a lot of weather going on at the moment, so thought I'd tell you that you saw we cut this off, and then I cut these parts off here. That was cut that outrigger off, and then I cut the outside perimeter off there. This one was initially supposed to go over there, but it was a little bit too short, so I put it here instead, where it's a little bit too long, which is all good, which means I can cut it off to my needs later on. But yes, thought I'd mention that we now have the first burnt in piece of metal, because burnt is what the cool kids say, so I'm trying to be one of them. But yeah, that is the first one that has been fixed. And the point of this one is that this is where the outrigger would be normally, but this one will allow us to have a little bit of extra space here going further down, and that could be useful for various things that we will probably talk about another time. Anyway, it is now it's now time for me to go inside and clean up and get ready for more work tomorrow. So, productive day. Let's hope we can continue the momentum. With that outrigger sticking out there and this outrigger sticking out here, we now have a place for the plan to go into, the sheet metal. And the sheet metal is now a very big piece. It is what I believe is called a half sheet. So that's there. And now I need to mark out these measurements and some other measurements, and then I need to cut it up, and then we need to bend it. It's pretty sturdy stuff, so I'm hoping that we won't need much reinforcements once it's bent. Things tend to stiffen up a lot when they're bent, so let's see what happens with that, but that's the current status.
This one is on me, lads and lassies. When I built my sheet metal folder, I thought I had over-dimensioned it. It's based on 100 by 100 by 10 angle iron. It's got a 1 meter bending capacity. Granted, it was never designed to bend almost 1 meter of 2.5mm sheet metal. Anyway, I completely underestimated how much force was required to bend this material. My overbuilt folder was bending like a gymnast on commission in a bendy straw factory. Our efforts were more akin to those videos where a car is sliding down the hill and a guy is trying to stop it. It was ridiculous. However, we got the last laugh when we got the abrasive cutting disc on the bend lines. Not so funny now, is it, Sheety McSheet Metal?
That took a lot more effort than we anticipated. And even though I made my sheet metal folder bender thingy, even if I built that overkill, there's a 100 by 100mm angle iron that is based upon. This 2.5mm steel that is almost 1 meter across, this thing, yeah, ain't gonna bend. Which meant that we ended up actually scoring the bends and also cutting through them. So yeah, that was a lot of effort. And also the handles on the bender are narrower than the bending capacity, which means that you can't actually grab onto stuff if it is bending over or something like that. Anyway, that was complicated, hard work, but here we go. This here is what you are going to step on when you step into the truck, and then there's going to be another step here. There's going to be a floor that's slightly recessed. It'll be butted up against the outrigger on the just behind the driver So yeah, now I need to figure out where I can add the reinforcement profiles to it so I can lock in the angles properly, because at the moment it's a little bit flimsy due to our extensive bending aids. So I need to weld it and put some sort of structure in, and then I can start fitting it to the truck. This is the bottom side, so that's the bottom of the countersunk floor. That's the wall of the stairs. That is the bottom of the lowest part of the entrance. I have got this part up here, which is just a L-ish shape thing. It's tack welded together, and I'm now checking the angles here. I've got this weird fireball tool square here for the right angle, clamped there, and then the magnets are on here to hold it in place. Then I have this other piece that needs to be mated up at that point there. So ideally I'd weld them all together, and then I'd do like one of those CAD model subtract or merge thingies or whatever. It doesn't really work like that in the workshop, so I need to figure out a little bit of a thing here or something, because I want the bottom of the panel to be flush with the bottom of that one, just like here. So, and then I want this lip here to be flush with this surface, and then from this miter here then goes to the other side behind the driver. And once I have that all together, then I can start trial fitting it. The bottom part of this panel here still needs to be narrowed down, so this is full width at the step. That's where we moved the outrigger a little bit further back, but then I need to finesse that bit into there too. So yeah, and I keep forgetting that this distance here isn't the correct one. That's the one I need to put on a truck, and then I need to trim it, because I need the vertical and the horizontals and all of the angles to meet up there. So yeah, that's kind of where we are at the moment. It's going quite well, so all good like that, but there's a lot of little things that need to be thought about, and they need to happen in a somewhat correct order and all things like that. So I'm not filming very much, because it's basically just fabric cobbling. It's cutting a piece, then chamfering it, making some angles or stuff like that, and then putting it, clamping it to the table, and then tack welding it and checking it and so forth. So nothing really super sexy stuff going on. So I'm just gonna update you when I have a little bit of a update to give you, and also when I need a bit of a break. This is the profile that I made today, and the box is going to go on the outer side of this, and we will need to adjust the forward reverse lever a little bit, but that's fine, because you can put it on the underside and you can do various other things with it, so that's not a problem. The things there line up well, the drop and all that stuff, so all that looks pretty good. And then I just stuck this stick there to give a bit of an idea of where the floor level is going to be. It's going to be on the underside there, but so we'll look from here. That's what it sort of looks like. And This here is going to be the step in the entrance, and the wall is going to go down there. So from this side you can see that there's a drop there for the extra 20 millimeters. So that's 80 plus 20, so 100 millimeter drop. Yeah, and then this one here needs to be cut off to match the box thingy there. And I'm pretty pleased with today's work. That sheet was a pretty big female dog to bend, but you know, with a bit of abrasive discs and stuff, everything seems to work out. Yeah! I wanted to show you a little bit about the philosophy of how I'm making this part. This is the part that goes on the front of the camper. This is the floor, and this is above here is going to be the hatch, the crawl through to the cab. That means that this one needs to be fairly accurate, because I'll probably end up referencing from this one several times in the rest of the build. So if this one is crooked, there's going to be consequences from that one. So when we did this brace here, we spent a long time making sure that this part here was parallel to this part here. We actually cut this piece 3 times. That's how bad we were. But my point is that we measured it, and we did it with maths rather than just fitting it in there, because I knew that there was a 0.5 degree difference between that joint and that joint, which resulted in plus 7 millimeters down here. So yeah, but now they should be fairly straight. At least this part is straight. That one is still bent from the welding here. So I need to make sure that these two here are parallel when I weld the upright there that is going to go up to the roof. So that one can only be welded when it's on the truck. These 2 uprights here were measured together, so they were the same, as in like I put them at the same time on the grinder or the sander to make sure that they were the same length, within probably 0.1 of a millimeter, maybe 0.15 or something like that. So they were pretty accurate themselves. Now I'm going to make a cross brace here. Like so. So I need to cut it to the correct length, but before I did that, I have made a spacer here because I forgot that I had these, so I only needed to make 1 spacer, but this is the Fireball tool blocks that are very accurate. So there's 190 millimeters of blocks here, and then I made this one 190 millimeters by putting it next to the blocks and scratching it, and then cutting it and then grinding it to the score line. So that one should be very accurate to that one. I checked it, and again it's within 0.2 of a millimeter. Now I then need to put this brace in here, so I need to measure it accurately and try to get that one as accurate as possible, whilst these pieces are in here to hold it parallel to that one. So yeah, that's sort of the philosophy that I'm trying to achieve here, is that I'm doing this by maths rather than just fitting it, because I need it to be straight, and I keep checking that all of the parts are as straight as possible. I just checked this line here, and it was straight. So, and then I'm clamping it down again with excessive amount of clamps just to hold it as tight and as accurately as possible. So, whilst I'm waiting for Kaz to get a moment to come and help me carry the tub out the stairs, thought I'd show you how this part is supposed to be sitting here one day. As you can hopefully see, that is lowering. The floor will go at the bottom of this part. It will butt up to this one, and it will butt up to here. So that is the 10 centimeter lowered part, and then it goes down to the stairs here. The part is now triangulated very well over there, so that should be very strong. These two uprights are sort of where the door, the crawl through will go, and then this part is also triangulated here. There will be an upright here. This one is temporary, will be removed when the other part is welded in. I've made this one at a specific height so that there should be no bending or problems just welding the other part in. I think it'll go out to about that width there where the mark is. I've clamped these plates on here so that we can just slide the tub in, but at the moment this looks very flimsy, but that is before the actual tub is welded in, and the tub is made out of 2.5mm thick galvanized steel. The tub itself will be part of the structure, and it will be attached to this one, and then this one will be attached to the side rails. So even if there's movement now, there should be considerably less movement when the thing is actually welded in place. So that's what it looks like now, and with a bit of luck, that mark there should match this one pretty well, which means that the door can come here. That is as low as the inside. There's a reinforcement beam there that is about that height, so this will be the height of the step-ish there. That's what it looks like from here. The side here will be obviously with a 40 by 40 by 3 meeting this one at the bottom here, and then this one should then be carrying a lot of the weight and the structural stiffness of this one. And then we have in here, we have the tub, and I welded the 10 centimeter raised bit onto there. I've gave that one a few welds in there, but the big thing was the welding of the side onto it here. So this one is now structurally sound, so is that bit. That is still the weak bit there, because I want to weld that when I have it actually clamped to the other side, so I get the angle correct. But that's the part we're waiting to lift into place, and I need my muscle woman to come help me with that.
The part that's hard to convey in a YouTube video is the amount of measuring, talking and thinking that has gone into this. We have spent countless of hours just standing around talking, crawling on, under, over the truck, measuring various things, debating the pros and the cons, changing our minds, talking more, dismissing ideas, trying another approach and so on. If you ever undertake any project like this, be prepared to do a lot of talking, measuring and thinking. The more you do this, the easier the actual fabric cobbling is going to be. Talk's cheap, you know.
This is quite a big moment for the habitat build. I have tacked the tub, the plate, to the front frame, and we have now used the clamp champ method of clamping it into place here, and it's very good. It's not perfect, but it's very good. So the interesting bit here is that with this edge here parallel, and this thingy here where I've clamped one clamp down there to this piece of metal and then that to there, and I put a little piece of metal in there, so this isn't square, but it shows that if I move here,
the movement is across everything, and yeah, it moves very well. Keep in mind that it's not fully welded yet, so this is as weak as it's ever going to be with these clamps in place. It's a bit of a discrepancy here on the gap. My bad. I don't know why I made it like that, but I did. I think the next step is to actually fully weld this into place, the tub here, and then I need to make a contraption to cover that up somehow. But yeah, it's looking good. Yesterday and Friday, when I finished welding the tub part to the front frame part, we were quite optimistic and quite keen on getting this welded onto the truck as soon as possible, i.e. today. But there were a few things that made us decide that we wouldn't do that. The first one was that I noticed that it was quite low on argon CO2 mix for the MIG welder, and it would have been quite bad juju if we would have started welding this onto the truck but would be unable to finish proper tack welds. So we decided that that was a good reason to not do that. Then we also realized that the front of the stairs box trellis frame thingy was open, and it's much easier to weld it here in the garage in a controlled environment than try to sit on the floor whilst welding it when it's actually on the truck. And we also had a few other paint and finishing things to do, so we decided simply that we will be working an extra day, and then hopefully we will have less stuff to do when this one is actually on the truck. With regards to these sheets here, they are 1.5 millimeters rather than the 2.5 millimeters that we use for the steps and the side there. We're not intending to clad the whole vehicle in steel, but I thought it would be a very good idea to have steel here at the front, where you might get some, especially down there, where you might get some rocks or something flinging up onto the bodywork, the camper. So also this will be extra structural super duper, so it will add strength to it too. It will prevent it twisting because it'll be welded onto the box section. So without further mumble, I am now going to weld this onto here. A few more days have passed and not much has happened apart from the paint has had time to dry. On Saturday I finished welding this and we spray painted it with the rusted red color, and then Kaz came here and started painting this, and by Sunday afternoon it was all painted black. Used to be a red door, red tub, and now it's painted black, so all that is good. And that means that this is pretty much ready to be installed on the truck. However, this sticky out bit here is just held in place by this U-shaped beam here, and that means that there is potentially quite a lot of flex in this one. If it would be a box section with 4 walls rather than 3, it would be a lot sturdier because the twist couldn't happen. Basically now this distance in the corner here could potentially change, even worse on the longer side, or it will change when you push it down. So my hopefully solution to that is to weld a triangulation in here that would take this twist out and transfer it to here, or sturdy it up that way. As you also can see, we have painted all the parts that will be almost inaccessible when the tub is on. We're getting close to putting the tub slash stairs slash entrance slash hallway into place. This piece is now welded in here, and the change in stiffness on this bar is remarkable. There is no flex in this point anymore, which is pretty cool. So yeah, that was worth doing. We think we are now ready to put the tub in here. I've ground this face clean. I've ground the paint off that one. We have also marked a line that is level with the bed, and by level with the bed I mean with the outriggers that are going backwards. So we have a datum to where we put the tub height there. We have put some wood pieces and some a sheet here, so hopefully we can rest the tub on here and slide it on without damaging it too much. I've ground off paint here in preparation for sealing that up. It's a bit nerve-wracking. At least we can put it in place and see if we actually get it where we want to, and then decide if we're going to tack weld it in or not, and then fully weld, of course, if it's fitting well. But we can put it here now, and we can take it back off if it doesn't fit well, or we need to do some modifications, if we have forgot something. That might happen. Let's do it.
The first part is easy. Slide the entrance tub into place. Then comes the verification. Check that every part aligns, that every measurement is okay. Measure again. If something isn't okay, figure out why. Confirm this is the actual reason. In our case, we needed to grind off a bit of 2 welds. Then redo everything again. Check every measurement. See that things align where they should align. Check again. Clamp into place. Check the clamps. Remeasure. Check. And check again. There's no point in proceeding until you're 100% satisfied things are fitting well and that you're happy with every aspect of it. Once you've decided to go ahead, you better be sure, or you'll create a massive amount of work for yourself. It's much easier to quadruple check and remeasure than it is to grind off all the welds and do it all over again. I don't think we could have done such an accurate job without this little device. The one I'm using is called a bevel box. It's a small box that measures angles. The cool thing is that you can reset it and then measure an angle somewhere else. In this case, we stick the bevel box onto a reference surface and then we stick it on something we want to measure. This way we don't have to have the flatbed perfectly level, and we can still confirm that the front wall is 90 degrees to the bed floor and so forth. Highly recommended, and they're not very expensive either. There's a link in the description if you're curious about them.
So what was that, an hour or two?
I think 2 hours, I think.
Almost 2 hours between lifting it into place and just doing 2 small adjustments in the corner where the welds were a little bit fat, and it's looking good. It looks like we're at the most 0.3 degrees out, and millimeter wise it's within 1.5 for the important measures.
Yeah, I'm pretty pleased.
So it's not perfect, but I guess it'll do. So I guess I'll just start bzz, 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 bzz.
Yay!
Okay, so let's do that then.
Let's get this done then.
As you know, this part isn't connected, only up here and around there, and that means that I now need to make sure that that wall is done as well as I can. And the idea here is that I'll put that 90 degrees square down there, and then I have managed to do some measurements around the center there, and now I have tons of things clamped, and I have tried to position everything as accurately as possible. I have these uprights here that are clamped to this one because this beam, unfortunately, I didn't manage to get completely straight for some reason,
and in general this is what it looks on the back here. So yeah, the whole idea here is that I am able to take a datum from these two outriggers, and then I've measured forward and I measured backwards and all that stuff. So I think that this edge here is now pretty straight based on that block, and then a few other lines here that I have measured. There's a measuring block up there too to hold it in place, so everything seems okay. Then the other thing I have done is that I have measured from the floor to here to confirm that that is one length. So I have now then got this level with that one obviously, and now I have pushed it down and I have measured from this edge to this edge several times to make sure that the first step is parallel with what will be the floor, because again apparently this beam isn't super parallel anyway. So yeah, this is the sort of things that I have to go through to get to this sort of measurements. And again, I probably won't be able to continue this sort of anal accuracy stuff, because once I have something to reference from that is fairly accurate, then I can be a little bit more relaxed about how I do these things. But as this is a large part of from what measurements is going to be taken, I have to try to make it as accurate as I can at this stage. Further down the line things can be less accurate, but if this floor is parallel with the other floor, then I can put a 90-degree square on it and I can make sure that an upright is actually an upright, and so forth. So I'm going to do a few more measurements and checks to see that it's okay, but yeah, it looks a little bit chaotic, and that's just on the outside of my head. Ding! So, morning chums and chumesses. Before I continue with today's shenanigans, I thought I'd give you a report on yesterday's shenanigans, because when I finished I was not only mucky tired but also very tired. Anyway, a little bit rested today. So this one has been burnt in, like the cool kids say, right? It's at a bit of an angle because this is in a bit of an angle, so my calculations at some point was a little bit off. Then I also welded in, burnt in this one here. This one isn't necessary for load carrying capacity, but despite being 2.5 millimeters, this did flex quite a bit. So now it is very sturdy. Now the next thing I want to do is I want to put a bar here. Again, I don't think it's necessary for load carrying capacity, but I think it would look a little bit better. And yeah, if I push on this one, it does flex a little bit. Another thing I need to do is I need to put a cap in this donkey's behind, or whatever the saying is. Basically, I need to cap this because there would be weather coming in from here. And also, I don't want a little shelf here for pixies or something like that to put their toiletries on, or whatever the thing is. So just a plate over here. To recapsile, plate there, stick there, and then tidy up all the welds. What I wanted to show you is how this is constructed. As I'm standing here, you can see that these two bars are pretty well triangulated. There is very little taking the weight up here. This here is the cross member that has got the pivot point on it. So
Anything from here on is a lever effect. One thing that we should keep in mind is that there's going to be very little weight in that corner. That corner is now completely over-engineered. This whole section is triangulated, and this 1.5mm panel is welded to the top and bottom and plug welded to the uprights here. This whole thing is a very structural piece. This is a very hefty piece of metal that is welded onto there. This piece of metal here is welded to the top completely, and inside here is a lip that is completely welded to this. This makes the whole thing very strong. This outrigger here, as you know, was welded straight onto this U piece here, and it wasn't that strong. The actual piece is strong, but because of this is a U piece, it wasn't that strong. Therefore, I added this reinforcement triangulation here, which prevents this one from moving up and down, and that made a huge difference. That was obviously before this panel was fully welded and this panel was fully welded and the whole thing was capped here. I've also added this one onto here, which prevents this from moving forward and backwards. Where these two uprights are, you can see there's some marks up on top of there. Maybe you can see that. That is where the crawl through is going to be. When you push down on this one is under tension. It is preventing from compressing there, and the tension continues over there, and then it continues down to the main beam there. So one question that I am no doubt going to get is how much does it flex? So I'm now going to do some exercise for you, and hopefully I won't get too healthy by mistake. Anyway, this is what it looks like. The camera is on the fuel tank, which is mounted to the frame. This is the frame. You are on the ground, the camera is on the ground, and this is the entrance, and this, and the pivot point is just up there. So let me do some more exercise for you. Another angle, you're now on the ground, fuel tank, exhaust, subframe, thingy under there, bounce, bounce. One more exercise angle. This is the outrigger that is attached to the frame pretty much rigidly. It pivots this way so you can't see much of that. The camera is on the rear tire, and this is the back of the entrance. Looks like that was shaking so much that I didn't want the camera to fall over, so I didn't bounce as much as I could. So there you have it. That is the entrance, and there is tons more things to do, but you are going to have to wait for another episode for that one. I hope you've enjoyed this type of format where there's less fabric cobbling and more thinking and thoughts about why and how things have materialized the way they do. So thank you for watching, and I hope to see you in the next one.